Hello everyone, welcome back to SCALER Academy YouTube channel. Myself Vamsi. In this particular tutorial, we will be discussing about the most important interview question on DPs named minimum cost of path sum. So this is the question which has many variations. Okay, so I can say that if you are able to solve this one particular problem, you can go ahead and solve 3 to 4 more problems related to grids on DP. When I say grids, it's equivalent to the matrices. Okay, so I highly recommend you to watch this video till the end. Okay, so before starting, so if you are visiting channel for the first time, don't forget to subscribe. If you like this content, please hit that like button up, and please let us know in the comment section how did you feel about this particular video.
So yeah, now let's discuss about problem statement. So problem statement will be given something like this. You will be given a grid or matrix, or also called as matrix, okay, with the size of m into n or n into m. So you will be given a matrix which is an integer matrix with the size of n into m, and you need to find the, okay, you need to figure out the minimum path, okay, minimum cost, okay, let's say minimum cost that it would take to reach n minus 1 comma n minus 1 from the 0 comma 0. Means you will be starting at the left top corner in the matrix, okay, so then you need to reach the bottom right corner, okay, with like inbuilt within the matrix, and you need to return the minimum cost, okay, minimum cost that would take to reach from that 0 comma 0 cell to n minus 1 comma n plus n minus 1. So here we will be having few constraints, okay, so the constraints are from a given cell, okay, from a starting cell, let's say this is your matrix, okay, you can only move to 3 steps, like one is to the right, and second one is to the down, and another one is to the diagonally, okay. So let's say if you are standing here, okay, if you are standing here, either you can move a right, you can move a down, or else you can move a diagonally, okay. So let's say, let's put some indexes here. So if you are standing at I comma j, then it would be I comma j plus 1, right? Then it would be I plus 1 comma j plus 1, then it would be I plus 1 comma j. So these are all the steps, okay, that you can do. Then you have to return the minimum cost, okay. So I will tell you, and I will give an sample input, okay. Let's try our things on that particular matrix, okay. So you will be given an 3 into 3 matrix, okay, where input is 2 1 2 3, then a 4 8 2, then 5 1 5 3, okay. This is the input which you have given. Now you need to you will be starting from this, okay, you will be starting from this. Now either you can make 3 choices, either you can move right, you can move this way, you can move this way, okay. So that's your choice. At the end you have to reach this particular cell, and so to reach that particular cell you will be taking some path, right? So among all the paths which you have taken, you need to return me the one which has took very less time, okay, very less time, okay. Let's say if you have taken this path, okay, so I have moved diagonally, so I have from 1 to 8, then 8 to 3, then total cost 1 plus 8 plus 3, so it would be like around 12, right? What is another path I can take? So let's say I have moved to 2, then I have moved to 2 to 3, then again I have moved to 2, 3 to 2, then again I have moved to 3. So 1 plus 2, okay, 3, 3 plus 3 it's a 6, 6 plus 2 it's a 8, 8 plus 3 it's a 11. Okay, another one with the 11. So if I took this path, okay, like 1 plus 4 it's a 5, okay, 5 plus 1 6, 6 plus 5 it's 11, 11 plus 3 14. So this is another way. And now let's talk about this path. Okay, so if I move to 1 to 2, then 2 to 2, then 2 to 3, like 1 plus 2 it's a 3, 3 plus 2 it's a 5, 5 plus 3 it's a 8. Okay, so this is how you will be calculating. So if you could observe, we will be having multiple paths, so we are interested in only the which is giving the minimum path. Okay, so in this case, for this particular input, this has to be your output. Okay, 8 is the one which gives the minimum path. Okay, so please pause the video for a while here and think of coming up with a solution. Okay, so as of now we have discussed plenty of we have solved plenty of questions on dynamic programming. So first come up with a recurrence relation. Okay, then try out drawing the recurrence tree. Then then we will together convert that particular tree to the code. Okay, so now let's get started. So here, so since we are from the very first video, we are considering only top-down approach, right? Top-down approach means we are starting from the n comma n. This is where we are starting. Okay, so then we are reaching the 0 comma 0, right? So here also we will do the same. Okay, if I am considering starting at this particular cell, then my coordinates will become up, diagonal and left, right? So if I say it's out this one, then it is going to be I minus 1 comma j, then it is going to be I comma j minus 1, then it is going to be something like I minus 1 and j minus 1, right? So these are all the coordinates that we need to identify, like remember. So let's start. Okay, let's start. Let me quickly have that matrix over here. So 1 2 3 4 8 2 1 5 3. So this is the matrix. Yeah. So now let's start with the recursion tree. So at every index, like at every cell, we do have a 3 choices. Either we can move, if we are starting top and down, either you can move up, can move down, sorry, you can move diagonally, you can move left. Okay, and we need to consider all the paths, and we need to return the one which we are giving very minimum cost. Okay, so let's say we are started at 2 comma 2. Okay, so now what are all the choices I have? So 3 choices. Okay, so first choice is going to be 2 minus 1, then it's going to be 1 comma 1, then it's going to be 1 comma 2. Done. So now let's write the cost of these particular paths as well, so that it will be easy for us to calculate it. Let's say here 3, here it is a 2 comma 1, 2, yeah, 2 comma 1 it's a 5, 1 comma 1 8, 1 comma 2 it's going to be 2. Okay, now from this particular 2 comma 1, again we can make the 3 steps. So one is going to be 2 comma 0, then 1 comma 0, then it is 2 comma, sorry, it is 1 comma 1. Now what is the cost of 2 comma 0? It's a 1. 1 comma 0, it's going to be 4, and 1 comma 1, it's again going to be 8, right? So and you will go on increase this particular thing again, like you will go ahead and increase on this 2 comma 2, then it is going to be 2 comma minus 1, which is not valid. Okay, so because we don't have any index with the minus 1, right? So so we will return a big number. So since we are considering the one which gives us the very minimum, so we can consider any big number like int max. Okay, now here it is again 1 comma 1, so 1 comma minus 1, so again we are returning int max. So at last it is going to be 1 comma 0, so for 1 comma 0 we will be returning the 4, and we'll go on increase this particular thing again, then we will see something like a 0 comma minus 1, so not valid. Again it's 0 comma minus 1, not valid. 1 comma 0 comma 0, valid. So uneven, so whenever you have seen a 0 comma 0, you can't move, like that is the reaching point, right? Whenever you have reached a 0 comma 0, you can simply return your answer over there. Okay, whatever the cost that is, have that. Okay, so here you have 1, so you will simply return 1. So you are done, right? So let's calculate the path from here. So 1 plus 4, it's going to be 5. Okay, so if you carefully observe from here, okay, from here we came to 2 comma 1, so we took this path. Okay, and then from here we came to here, and from here we came to here, then from here we came to here. Now what is a path, a cost it took to reach here? So among all this, like int max, so it will return, so minimum would be 1, and again it is 5, so among all these three, 5 is the one which is minimum, so you will return 5. So 1 plus 5, it's a 6. So now you need to grow this side, and as you know that for a 1 comma 0 index, so like 1 comma 0, you required a 1, you will be getting 1. So to reach here you will say you will return 5 here, and we'll go on solve for this guy. Okay, 1 comma 1. Okay, so it is going to be 1 comma 0 and 0 comma 0 and 1 comma 0 0 comma 1. So 1 comma 0, again you know that 1 comma 0 is going to give you the 5. Okay, 1 comma we will return 5 here, and 0 comma 0, so if you reach 0 0, you will simply return 1, which is the cost that it took, and 0 comma 1, so 0 and 1, so it is 2. Okay, still you have three choices you can make. So you can go 0 comma 0, 0 minus 1 comma 1, so which is not valid, so you will return int max again. So here it is again going to be same story, so minus 1 comma 1, so negative, so you will return int max over here. So the one which is again 1, so it will return 1, so 3. Okay, 3, so 3, then you it will return 3 here. Among 5 and 3, 3 is the one which gives a minimum, and 1 comma 1 is 8, so 3 plus 8, it's 11, so you will return 11 here, and from here you will return 5. Okay, and from so here you took a path of 1 4 4 plus 5 6 6, you will return 6. So among 6 5 8 11, 6 5 11, so 1 comma 0 will return you 1, so it's a 5 here. Yeah, 5. So 6 5 11, so you will return 5, and like 5 plus 5, yeah, it's a 10. Okay, now you will go this side, and you will do the same task. So I guess it is the one which gives us the minimum. So let's go and draw this tree for this particular thing. Okay, so 1 comma 2, did we solve that problem earlier? No. Okay, let's do this time. So we will be having three things. Okay, 1 comma 1, 0 comma 1, and 0 comma 2. Okay, then again it is going to be 1 comma 0, and it is going to be 0 comma 0, and it is going to be 0 comma 1. So you know that 1 comma 0 will return you the 5. Yeah, 1 comma 0 will return you the 5. So let's return 5, and 0 comma 0 will return you 1, and 0 comma 1 will return you, I hope we have solved this. Yeah, so here, so at the end, like it is going to return 3. So among all this, 1 is the one which is a very minimum, so you will return 1 here. Now you will go and draw this up, and 0 comma 1, I guess we have solved that, so it will return 3. Okay, so 0 comma 2, did we solve that already? No, I guess. So let's go and solve this up. So again you will be having three options. So minus 1 comma 2, which is not valid, minus 1 comma 2, which is not valid, sorry, minus 1 comma 1, which is not valid, and here it is going to be my 0 comma 1. So yeah, yep, we have solved, decrease this. Yeah, we kept this, so we'll keep that and we'll decrease that. So again 0 comma 1 is going to give you 3. Sorry, 0 comma 1 is going to give you 3, and which is very minimum, so you will return 3 plus this 2 comma 05 cost. What is the cost of 2 comma 0 comma 2? 0 comma 2 is 3, so 3 plus 3 is 6, so we will return 3. So out of all these things, so here we will be getting 1, so 1 plus 8, 1 plus 8 is a 9. So among all these things, so 3 is the one which is minimum, so 3 plus 2 it's a 5, 5 plus 3 is a 8, so here it will return 5. So among all these paths, so you will get 8. Okay, so 5 plus 3 is 8, 3 plus 3 plus 8 is 11, 3 plus 5 is again 8, so the minimum one is 8. So this is how your recursion tree looks like. Yes, it's a messy, but I highly recommend you to draw your own tree, then only you will be able to solve a few more problems. And this particular problem has a lot of connecting problems. Okay, so here we will be starting from the one particular cell, like starting, and we are reaching the ending, but there will be there will be another problem, okay, where you can start from here, you can start from here, you can start from here, that is valid. Yes, so and this is one problem, and there is another problem. So here we have considered only three things, like we can move one diagonal, right, and down. So there will be a problem where you can go four sides, left, right, up, down, and there is another problem which tells you go diagonally only, something like this, and there is another problem which tells you to go 8 sides. Okay, 4 diagonals, 4 ups and 4 downs. Okay, 8 sides. So this problem has lot of connecting problems, so please do solve this one particular problem. Okay, you will get to know 5 to 6 more problems you can solve. Yes, okay, so please google that. Okay, you will hear a lot about this question. Okay, now let's try to write the code for this particular approach. Okay, recurrence code. So let's assume that we have a function called a get minimum, and we will be getting n comma n. Okay, so where m is our row, n is our column. Okay, and let's write this code. Okay, so what will be our base cases? First base case, can I write if m equal to 0, and n equal to 0. Then what we need to return? So we need to return just cost of that matrix, that particular cell. Yes, that is it. And another condition, if either of the either m or n will reaches the index less than 0, then what we need to return, what we have returned in our recurrence tree, we have returned something int max. So let's say 10 1 e power 9, okay, 10 power 9. Then in all other cases, we need to do something. So what is something? Let's say we do have three things, right? Into left, okay, into left. So if I am moving left, then what it would be? So I am lying in the same row m, and I am decreasing my column. And if I move to up, then get min, I will be decreasing my row, so m minus 1, but I will be residing in same column. And if I am moving onto diagonally, then I am decreasing both my row and column. Now after moving all to the after taking the path in all the options, now what I need to do, I need to choose the one which is very minimum. Yes, so let's say int answer equal to minimum of left comma minimum of up comma diagonal. Yes, then I need to return that answer. This is how, if I write the code whatever we have seen, this is how it looks like. Agree? Now let's go and code this particular solution. Okay, at first what we need to do, we need to have nnm, and then m. After that we need to take vector of vector. So let's make it as a cost, so where the size will be n into m, and then run the outer loop for m times, and run the inner loop for the n times. Then take this cost of I j. Yes. Now say answer is equal to get min path. Okay, get min path of n minus 1 comma n minus 1. Why n minus 1 comma n minus 1? Because if I took a 3 into 3 matrix, what will be my bottom right corner index? It is going to be 2 comma 2, right? So that's why I have took n minus 1 and n minus 1. So at the end I will go and print my answer. Now let's go and fill this particular function. So let's say int, then I will be having vector of cost. Yes. Now what are our base cases? So if whenever n and m equal to 0, then return cost of n and m. You can simply return cost of 0 comma 0 as well. Otherwise, if either m less than 0 or n are less than 0, then return 1 e9. Yes, if you don't want it to stuck in overflow, then you can simply do -1. And in all other cases, you will be moving three options like left, up, and diagonal. Okay, so if you are moving left, then you will be residing in the same row, then you are decreasing one column in cost as it is. If you are moving up, then it's then you are moving column down, row up, then same column, then cost. If you are moving diagonally, then it is going to be it in n-1, n-1. Then your answer is equal to minimum among all these three. So minimum of up, comma, diagonal. Okay. At the end, just return answer. That's it. So let's go and simply provide some inputs. So we are considering 3 comma 3, and we took 1 comma 3. Yeah, 1 2 3 4 4 8 2 1 5 3 4 8 2 4 8 for this particular input, 8 has to be our output. Let's see. Yes, we forgot to pass the thing. Yeah. Now let's save this code and let's build this solution. Took some plenty amount of time, but we got 1 as our output. Okay, sorry. So here we forgot one thing. What is that one thing? Can anyone guess? So basically, if we are taking some path, we forgot to add the cost of that path. Okay, so yeah, it's m plus like cost of sorry, my bad. Yep. Now let's go and save this code and let's run this, build the solution. I think this should give the output. Yes, we got the output as one. Now what next? So the complexity of this approach is going to be big O of 3 into n, like big O of 3 power n into m. Because we have three choices, then it's going to be 3 power exponential. So how can we reduce this? So what is the first step of optimizing a recursion solution to the dynamic programming? So first of all, go and identify what are all the changing factors in your code. So the changing factors, I can see that m1 n. So there were two changes every time. So that it means that I need to have a 2D DP. Okay, 2D DP. And int dp of so wherever you are making a call, don't forget to and here let's copy this, let's go up, let's put it here, then let's paste this here and we'll pass in all other cases okay. And at the end so before yeah, let's fill this with -1. Okay, so before making a call, just check whether you have already solved that particular problem or not, then you won't get into an overlapping problems, then m. So at the last, if instead of returning the answer directly, just store it in your DP and then return. Okay, so yeah, now let's see what it will return. Okay, okay, sorry. So that is right. Okay, so if I give any other input, something like let's say 2, 1, where we will be having 2 rows and yeah, so 2, 3. Okay, where we will be having 2 rows and 3 columns. So let's say 1, 2, 3 and 0, 1 and 1. Okay, now I guess our output should be this path. 1 plus 0 it's an 1, 1 plus 1 it's a 2, 2 plus 2 it's a 3. Okay, so yeah, let's run this code up. So yeah, we got 3. So it is returning a good answer. And yeah, so that is pretty much, I guess. And still, if you wanted to do further optimization, I know that I have taught the plenty of times like how to convert your recursive code to the tabulation method. So please try to do it on yourself. Okay, please let us know in the comment section whether you are able to do that or not.